Okay, so we are moving along to um, part three of module five. So last time we talked, we were looking specifically at geographic time in the fossil record. So now we're going to think about how geologic time and that fossil record influence how and where species are distributed throughout the world. So a question that we can sort of think to sort of drive this is, why are there no penguins in the North Pole and no polar bears in the South Pole? Ultimately, the distribution of their organisms not only reflects how well a species can survive in a given environment, but also reflects their evolutionary history. And this is the study of what we call biogeography. It's really understanding how organisms are distributed in geographic space. And ultimately, one of the things that really influences biogeography is plate tectonics, or sort of the movement of where plates are. Because again, we're thinking in terms of evolutionary history. So we know that we had differences of where land masses used to be and are now, and that, again, in terms of evolutionary time, can dramatically influence where species ended up. So let's look at, for example, the penguin. So this was the evolutionary history of the penguin. And ultimately, the penguins first appeared around 65 million years ago in what is now New Zealand. And that, again, is in the south. And then through diversification of these clades, they more or less were able to colonize throughout the southern hemisphere. Whereas looking at polar bears evolved from brown bears in Siberia, and then they became isolated by the glaciers and lived specifically in the north. So these are the sort of questions that biologists start to think about when they're looking at species distribution in an evolutionary sense. But for example, there are creatures that look alike but are not always closely related. This is something that we call convergent evolution, where common ancestry is not really the only reasons why two species appear similar. Ultimately, organisms that are not closely related can evolve to have very similar adaptations as a result of independent episodes of natural selection. So a great example of this is the flying lemur, the flying squirrel, and the sugar glider. Now, all of these species evolved to have a very similar trait where they're able to sort of glide. However, they're not directly related to one another. This is just an example of randomness in evolution, where species basically evolved similar traits because that similar trait ended up working for them in their environment. And there's lots of different examples of this. So keep in mind, if two creatures look alike, it might just be because of convergent evolution, not because they're related in some way. So thinking through this idea of evolutionary speciation, we started to come into the idea of taxonomy, or really how biologists start to classify and label and understand the interrelatedness of different creatures. So you've probably talked about this in other science classes that you've had, and how we think about naming these creatures, naming different species. And ultimately, we have this very distinct order in biology where we look at kingdom, the phylum, the class, order, family, genus, species. So with the largest one starting at domain. So we have all of life, then we go to domain, then kingdom, phylum, class, order, family, genus, species. So if we look at this chart, this sort of gives us an idea of what this looks like. So at the very top, we have these kingdoms, and that, for example, kingdom Animalia includes all of these things. Then we start to go to more specific things. We go to the phylum, we go to the class, order, family, genus, and then species, where you have a very specific animal. at the very end. And so this is sort of how we classify life on Earth. So, and ultimately, this is sort of the study of what we call phylogeny. It's understanding the evolutionary history of a group of organisms. And this is what, and we represent these closely relatedness in something called a phylogenetic tree. And I have a great video that I'd like you to watch that sort of looks through about how we read phylogenetic trees as biologists. But one of the things that we can look at here with these things is understanding how closely related something is. So, is the crocodile more closely related to a bird or a lizard? So, keep this in mind and think about this when you watch that other video. But ultimately, this is just a way to understand the evolutionary relationship of different animals. And then we can zoom out and really understand uh, where we are throughout this family tree that we've created. Um, and this is looking at sort of a large section of the tree going through all of these major different organisms. And ultimately, that's what we're going to be focusing on in this next module is understanding organismal biology. So understanding the characteristics of these different main life groups on Earth. So that's where we're going to be heading in this next module. See you soon.